Hello viewers, welcome to another Arduino programming series. In my last video, we have learned how to generate analog output. In this video, we will learn how to read the analog values, and this is very important because most of the sensors they generate analog output. And for this I am using a very common temperature sensor which is LM35. So it senses the temperature and based on that temperature it generates the output voltage. Please do follow me step by step in order to understand each and every command. The first step is to include this header file liquidcrystal.h. This header files contain all the library of the LCD. The next command is to assign all the pin numbers a variable name. For example, the pin number 2 is equal to D7 and D7 is the pin of the LCD. So this is how you will easily remember that pin number 2 of the Arduino board will be connected to pin D7 of the LCD. Similarly for all the pins, and for interfacing the LCD with Arduino Uno, we use 6 digital pins. In the next step, we will define some values to the variable. For example, ADC V reference millivolt is equal to 5000. It means that for ADC we have to give some voltage reference. In this case our voltage reference will be 5 volts. Then the ADC resolution of Arduino Uno is 1024, which is equal to the 10 bits ADC. And then the analog pin. Remember, in order to read the analog value we have to use the built-in analog pins of the Arduino board. In my case I am using A0 pin. I defined this pin as pin LM35. Then comes a built-in function of LCD which is liquid crystal LCD, and within the argument we have to give all the pins we have initialized. Then comes the void setup function. In this function I will use this command lcd.begin. Within the argument I use 16, 2. Within the infinite loop, the first step is to read the analog voltage by using the function analogRead, and within the bracket pin number which is A0, which is equal to pin underscore LM35, and this function must have a return value, and I am storing this return value in ADC val. This is the formula to convert the digital value into the analog value. So the formula is the digital value multiplied by the V reference divided by ADC resolution. If you have a 10 bit, then you divide it by 1024. If you have 8 bit, then you have to divide it by 255. The temperature will be equal to millivolts divided by 10 because every degree Celsius is equal to 10 millivolts. For example, 25 degrees Celsius corresponds to 250 millivolts. Therefore, we have to divide it by 10 in order to display in degrees Celsius. And afterward, there are some built-in commands of LCD. First, we have to clear the LCD every time by using the command lcd.clear. Then comes the command lcd.setCursor 00. This will set the cursor at the start of the first row and first column. 0 means first column and 0 means first row, by using the command lcd.print. So this will print the value stored in the temp C on the LCD. Again, I am using the same command lcd.print to print the character C for the Celsius. Remember to put the delay at the end of the routine because all the ADC converters must require some delay to convert the digital value into the analog value. So this is how we read analog value, and this is how we display the values on the LCD. Now let's check the program. First, we verify the program. The next step is to go to Sketch and export compiled binary. Done compiling. Then go to show sketch folder to get the hex file address. Here is the hex file. Copy the address. The next step is to check the functionality of the program in Proteus software. So this is the hardware. I have connected the LCD 16x2 LCD with Arduino board according to the pins already defined in the program. This is LM35 sensor. It generates the analog voltage, and the pin number 2 is the output pin of this sensor, and this is directly connected to pin A0, which is used as the analog input pin in Arduino board. Next step is to give the address of the hex file. Now run the simulation. Here you can see the temperature sensor is sensing 29 degrees C and it is displaying 29.3. So this is the analog to digital error, and you can remove this error by amplifying the output signal of this sensor. So this is how you can read analog signal, and this is how you interface the LCD. I hope you like this video. For more interesting videos on Arduino programming, stay tuned and don't forget to subscribe our channel. Thank you for watching.